Okay, so this one is a bit fun. So here we get into a little bit of color theory. So the traditional way of representing colors, like the old school way, is to represent them using something called RGB. So RGB stands for red, green, and blue, because all normal colors you can decompose into how much of these different elements are contained in the color. So red is R is of course red, green is green, and blue is blue. And these would be numbers between, in this case, 0 and 1, although different programs will use different scales. There are many other ways of thinking about colors and representing colors outside these three numbers. And one is using something called hue and also some other coordinates, but this will only consider the hue. So what does that mean? It means that you represent the colors as a wheel, and then the hue reflect where on this wheel you are. So now of course you need a way of converting between an RGB color, like maybe this one, to which angle you are on this wheel. And there are formulas for doing that, and here's a formula for computing the hue. So that's what we need to compute here. We need to figure out what the hue is. And the hue has to be positive, so that's a correction. So that's like a whole recipe for computing the hue. I'm just going to wing it. I'm going to start from the top and see if we can get it correct, and otherwise the test will complain and correct us. So here's how we represent an RGB color. We do that using tuples, because that is the subject of today. So this will be a color that's predominantly red, blue, and green. So I guess it's like sort of on the yellowish side. I get a little bit. I'm not really sure. I'm not an expert. But this is a color, and then we put it into our RGB to hue function, and it should return 345. So let's try to pay attention to that number, 345, because that's where we want to end up. Okay, so explore and RGB to hue. Let's put in this example. Hue has to be computed, and then eventually we want to return it. So I put in a breakpoint because I print should be 345, and then we print out this value here. Okay, so now that I put in a return statement, I can start the debugger, and I select debug. When I do functions like this, I really like the idea of using the same symbols in my program as I have in the problem. I feel that when I do numerical stuff, I feel that really simplifies my life a lot. Okay, so the first thing we need to do is we need to compute this delta value, delta. And delta is equal to the difference between the minimum and maximum value. Or I guess it's the other way around, the maximum and the minimum value. Well, we can get this RGB tuple is this way, and we can get the maximum value using the max function, exactly the same as with lists. And then we can get the minimum value using the min function, and that allows us to compute the difference. And now we see there's a little bit of a floating point error, but that's fine. Floating points are not completely exact when you compute differences. So that allows us to compute delta, and I guess that's correct. Now we have a big if-else statement. So we have to define R, G, and B. R, G, and B, and I do tuple unpacking. So I can just define them like this. Let's confirm that it works. It worked. Fine. So now I need to check if R is the largest value. So if R greater than or equal max RGB, then I need to do 6 times G minus B divided by delta. 60. Then H equal 60 times G minus B divided by delta. Oh, this is going to be so fun. Otherwise, if G is the largest RGB value, I need to do this. Is there a way I can copy paste here? Let's try. It's probably going to end badly, but let's try. Yeah, that's probably not helping me a lot. So let's do it manually. Else if G is largest, G greater than or equal the maximum of RGB, then it's 120 plus, so we are sort of moving around in angles here, 120 plus 60 times B minus R divided by delta. 60 times B minus R divided by delta. So I guess we can do a little bit of copy paste Arimo here. So the last condition is always met because one of them has to be largest, or at least as large as the other ones. So if the blue component, so I can just do else here. Else the blue component must be the largest, and then it's 240, and then 60, and then it's R minus G. R minus G divided by delta. And I seem to have forgotten a little because I have to assign this to the hue variable. Like this. So now we are so far, you can assume that it's different than 0. So this doesn't work if the color is like, if these have the same value. And what happens if they have the same value? Well, in that case, the color is actually a grayscale, like it's a gray color. It could be white or black or some gray color. In that case, the hue is not defined because hue has to do with the color component of this scale. So I'm not completely confident about what the hue would be for gray color, but it probably has some trivial value like there must be a way of handling it. It's just not included in this problem. If two are the same, okay, so that's just confirming that this is okay even if two have the same value. If it's negative, we add 360 to it. So if Q is less than 0, then we say that it's the same value as we had plus 360. And that's because it's an angle, so we always want the angle to be from 0 and up to 360. Then I remember to remove that line because otherwise it will look a little bit silly. And now let's try to run all of this stuff. So Shift Alt E, and let's see what the hue became. That seems correct. So that's how I can do that. Let's end it, the debugger, and just run the code to confirm that it seems to work. It seems to work. But there are like a lot of, like a problem with this code is there are a lot of special cases here. So this could be based on, this is based on one of these cases, and we don't really know if it works in the other cases. So we need to, the tests are quite important here. So I guess it's this one, and it was correct. So that's good. So I guess that's how we can do that. So I hope that was informative, and we, at the very least, we learned a little bit of color theory, which is always nice.